I'll start sharing my screen, and maybe this part, or okay, let's share what okay, let's share this tab. And now, can you see the screen? Can you see my screen?
The image shows the Google AI Studio interface.
Right.
It prompts the user to build something and push Gemini to the limits of AI.
Exactly.
There are options for code optimization, unit testing, and twisted search.
I want to start optimizing my code. Which of the options can I choose here from the screen? Can you guide me?
From the screen, you can choose the Code Optimizer option to find time complexity and optimize your code.
Okay.
Alternatively, you could select Unit Testing to add unit tests for a Python function.
All right, I'm just going to do that. I've clicked on the code optimizer, and I can see some codes currently
The image
running.
shows the Google AI Studio interface, asking, "What will you build?" You can choose from options like Code Optimizer, Unit Testing, or Twisted Search. On the right, you can adjust run settings, select a model, and view token count and temperature.
Yeah. And now, what do you see?
Okay, I see a screenshot of Google AI Studio with Python code for a
Right.
bubble sort algorithm. The instructions ask to identify the time complexity, optimize the function, and explain why the optimized version is faster. It also specifies not to use the inbuilt sort method.
Okay, thank you very much. So I stop sharing here. All right, guys, you can see that was a demonstration of exactly the same functionality like Google AI Studio. So let's see that in action here. So I'm going to share my screen, and I will share this one, exactly the one we shared with the local model. I'm going to allow all the time. Hi, can you see my screen?
Okay, I hear you. Yes, I can see your screen. It looks like you are on the Google AI Studio website on the stream.
Yeah, that's correct. I would like to tune a model today.
Okay, I see. You're looking at the stream real-time page on the...
For some reason, I don't know why it's cutting off.
Okay, I see you want to tune a model. Do you have a specific model in mind, or would you like me to help you explore the available options?
I want to tune a model. Can you help me do this?
Okay, I hear you. It sounds like you're experiencing some technical issues with the stream. Is the issue with the audio or video, or something else?
It's actually with the audio. In fact, I don't know what is the problem here.
Okay, you'd like to tune a model. Is there a specific model you have in mind, or would you like to explore the available models?
All right, thank you very much. Thank you very much. Yeah, you can see that that's something very similar to what we have here. So what is this? This is obviously an open source stuff. I'll put the link to the code in the description. But what I've done here is I didn't write this front end. I took this from someone online. I found this code somewhere where this guy was trying to do something of some sort, but he was trying to do something with Olama with the Coin VL model. The Coin VL model, it's very GPU hungry, and this my system would not be able to run it. So what I'm doing here is I replaced that with the Google Gemini 2.0 Flash. I refactored the code, and the rest is exactly the same. So all you need to do here is to put in your Google API key and specify the model that you want. I'll put the link in the description. So what is happening here? Let's look at this. I will run through the code very quickly. I don't want to be too technical in this video. So there are two files here. There is a main.py, which is the one for the local model. I tried to use Olama to run this. using the Gemma 3, the new one that just came out. It works, but it's very slow, as you can imagine. So I opted to use the cloud version of Gemini. So here is an audio segment detector. This audio segment detector is to detect when you start to speak and when you stop. Like it detects it intuitively, so that you don't have to specify when you actually stop talking. It just detects that you stop talking and sends the entire stream, that's your vocal stream, your audio stream, to the text to speech model. In this case, is Whisper. So it sends it to this Whisper transcriber. The Whisper transcriber here, we are using the large, but anyway, I decided to use to go with the Whisper small, because again, the capacity of my system. This is a Mac system, so I'm deciding to use the Whisper small. And as you can see, there is no CUDA on this system. There's only CPU, so every time it uses the CPU. So after transcribing that, it sends the transcribed message to the multimodal model. In this case, it's the Gemini 2.0 Flash. So again, put in your key, and all I'm doing here is that it takes a chunk of that video stream that you're seeing is actually streams of images. So every time that you share your screen here and something changes, it captures that as an image. So it sets the image, and all we are doing here is just to convert this to display image, and we pass this image into this generate method. So eventually you have that self.last image, which is what we need here. So this is the content. In order to generate content from the Gemini 2.0 Flash, this is by the documentation of Google. Just go to the documentation and you will see that this is exactly what they have there. Specify the model name, specify the content. So in the content, you can take in the text. The text in this case is that transcribed text that comes from your voice. When you say, "Can you see my screen?" for example, that text is the same text that comes in here. Apart from that, we have the system prompt that I've given here. It says you are a helpful assistant providing spoken responses about images. Remember that the idea is not exactly video, because video is just a stream of images, right? So we say that you are an assistant that provides responses about images, and we say keep it very short, 2 to 3 sentences. Ask the user to repeat or clarify if something is not clear. We pass in all that prompt to the system instruction, set a temperature, the max token, and the content. Once that is done, it gets the response, and again, the Kokoro TTS model is the one that then takes the generated text, because this response content will come in as a text, not a streaming text this time, because we don't want to stream the text. We want all the text to come in at once. And then we take this Kokoro TTS processor, there's a model, the TTS model, and we put that and convert the text into speech. We are using this AF Sarah as the default voice. You can also check the Kokoro TTS model. I think I've demoed something on this before. If not, if you're interested in that, I will make a separate demo. And once that is done, we combine everything into a WebSocket. So this is a WebSocket. The WebSocket eventually runs on the port 9073. This is the port I chose, so you can choose whatever you want. And you need to set some parameters like the ping interval, the ping timeout, and the close timeout. So eventually, this project starts to run. All you need to do is to do Python, just run Python cloud main.py, just like so, and it will start. Of course, before you do that, you need to install all the requirements here. And if you are new to that, what you can simply do is first create an environment. So to create an environment, we do Python. In this case, I'm using venv venv, something like this. If you do that, it creates an environment like so, and that's why you find this venv folder. And then after creating that, then you need to activate it. To activate it, you do, if you're on the Mac, you do source venv bin and activate. If you're on the Windows, you need to find the corresponding commands to activate your environment. Okay, once that is done, then you install your pip install r and then requirements. So this requirements.txt, you install this requirements. If everything is installed properly, then all you need to do is to run python cloud main.py, like so. If you do that, then you have your server, and you would have something like this. You will see something like this. So all the processor is initialized, and then the WebSocket starts at 9073. Now, after that, you should come to the front end, because this is only the back end that processes the voice to speech, the text to speech, speech to text, and the model generation content and everything. You should then come to the front end side. This is just a Vite application with React. And here, if you come to the app.tsx, let's increase this one a little bit more. All you need to do is set your WebSocket at the port. So WebSocket, not HTTP, but WebSocket 0000 at 9073, and that's all you need to do. That's basically all you need to do. So if everything works well, of course, on this application, this is a React application, so the first thing to do is to install your node modules. So you should do npm install when you get this, when you clone this repository. Open this and do npm install, and the next thing to do is npm run dev. Finish. That's all. And here is it. You just run dev. It runs with Vite, and Vite is on the default port of 5173, and that's why we have 5173, and everything works. So that's all I need to share. If you have any question, or if you want more details into how this was put together, leave a comment in the comment section, and I will see you there. If you want me to explain any part of the video as well, do leave a comment. And if you want me to make another video of this type of thing going forward, then leave a like, leave a subscribe, and I'll see you in the next video.